Okay, everybody. Hello, this is Dr. Marston. Here we are in the quantitative. Um, here we are in quantitative uh, uh, statistics, quantitative research design, class number 8. This is the video lecture. And just a couple things. One is I do apologize for getting this in late. I had a little bit of scheduling difficulties earlier. By the time you get, I always try to have this in by 6 a.m. your time Tuesday morning. By the time you get this, it'll be probably closer to 9 a.m. your time. So hopefully it doesn't set things back too much. Um, I was I jumped right into this and didn't recheck the syllabus. So make sure you're checking the syllabus to confirm that you are up to date on all of the assignments that are due this week. Um, and we will be moving forward here into. Oh, and the other thing is after this is done, I will uh, have the article online that you are going to be expected to read for this week. So this week we're going to talk about meta-analysis. Um, so meta-analysis is a statistical procedure that I brought up before, and I made mention of this to you before, that I particularly like because it is a statistical procedure that does not require you to collect data. I thought I just would, before getting into meta-analysis, go a little bit into this, and that it is, I think it's particularly useful to be familiar with the types of research that you can do that does not require you to collect data. Not that collect, I mean, collecting data is, I mean, is the hallmark of research. So I don't talk about it this way to suggest there's anything wrong with it. That would be ridiculous, of course. It's the, like I said, the hallmark of research. But I would have to say that collecting data is probably the one aspect of research that is the most difficult uh, for people who are primarily clinicians. It is just difficult to do. If you're a full time researcher, if you're a full time academic, um, it is something that is much more available to you. You have more participants available. I've talked to you before about how um, one aspect of research, psychological research, is that many of the subjects in research experiments are college students, and that is because the people conducting the research are college professors, and they have access to students. So that's who they use for the research that they're conducting. Um, there are uh, there is more opportunity to have resources available for collecting the data. You may need a series of multiple computers if you want people to enter in the data, if you want them to take experiment, if you want them to complete tasks. Uh, so, to a large degree, um, college professors have much more access to the resources and the individuals needed for um, conducting research. Okay, so when you're a clinician, especially if you're in full time practice like I am, collecting data becomes much more difficult. You might say, someone might say, well, you can collect clinical data because you have patients, but that doesn't take into account um, the fact that these individuals are not coming to you for research. They are coming to you to get help. So collecting the data for your research has to take a back seat. It's something you can do. You can certainly ask um, individuals to allow you to collect certain data for research, but you have to be prepared for what if they turn you down. It's not like if a researcher is conducting a research experiment and they ask someone to get involved and that person turns them down, they can just move on to the next person to get them to agree. But if you are working with someone as a clinician and you ask them to let you collect data and they turn you down, you cannot then just turn your back and say, well, I'll just move on to the next person. You have to continue working with that person because they are your patient. They are someone that has come to see you clinically, and their refusal to participate in your research experiment is not um, a reason that you can then say, well, then I choose not to keep working with you. You have already made a commitment to keep working with them. So for those reasons, collecting data as a clinician can be a challenging situation. So I like to spend some time talking about what are some alternatives for collecting data if you're a clinician or if you're not a full-time academic. By the way, I fully am aware that I am talking to you about the difficulty collecting data if you are not a academic. Yet I am your professor for this course, but I am not a full-time professor. I am not a full-time academic. I am what's called an adjunct, which you probably aware. Adjunct basically means part-time. I'm not even part-time. Part-time to me in the quote unquote real world, it means that you have a formal ongoing position with a company or a store or a business, and you have a certain set number of hours that you work each week, and you continue to do that up until the time that you sever that relationship, either because you quit, you get fired, hopefully not, but you get fired, or just you reach a mutual decision that you're going to leave at a certain date. Adjunct professor doesn't work that way. I, um, my position with schools, and I teach for different schools, CIHS being one of them. My position with different schools um, lasts formally only for as long as the course lasts. Um, I do once I am done at CIHS for this course, then I formally do not have a position with CIHS until the start of the next um, semester. I do not have an ongoing relation. So my access to materials through a university is rather limited because I do not have an ongoing formal position with them other than my job for the schools I teach is literally just to teach a course. I try to do more for students. That position has changed slightly lately because I started taking on dissertation students, and that tends to be you tend to have a formal relationship with the school when you are a dissertation chairperson throughout the time that those students are working on their dissertations. But for the most part, my only job formally with schools is is to teach a course. Now, as I said, I try to do more than that, and I certainly don't hold to that as the only thing I do and the only role I try to take. Um, but I bring that up in the context of I then have very limited resources to um, any resources that CIHS might have um, other than for when I teach a course. So even if CIHS did have materials that I could use for collecting data, I do not have ongoing access, so nor do I have ongoing time, because if you're a professor, part of the that's the other thing, is if you're a full-time professor, part of the expectation is that you will conduct research. So that's actually part of your job. When you're an adjunct, that is not part of your job. So where am I going? I'm just bringing all this up to let you know why I think it is important when you are looking to go into the clinical field to understand other alternatives that can be available to you for conducting research that do not involve um, having to collect data on your own. Now, most of the ones that are available, um, there are a couple of them that I've talked about in here. Most of them would be either in the area of qualitative research or actually not in any particular research design at all. That category, the one that's not a particular research design, would be um, qualitative literature reviews, comprehensive literature reviews, where you basically um, review the literature and draw a conclusion about what that literature says. You know, we talk about literature reviews in here as part of formal papers, but we usually describe it in the context of the literature review being the first part of a research paper. The literature review reviews the research, draws a conclusion about where the research is, and then sets the stage for making the hypothesis and for describing the research design. A comprehensive literature review is a literature review in and of itself. Like that's the only thing that the paper does, and the purpose of it is to say this is where what the literature says, and these are some takeaways from a comprehensive review of what the literature says. For this course, for this class, I will be sending to you articles on meta-analysis and meta-synthesis. I wrote both of those articles with another professor. Those are comprehensive literature reviews. They were submitted and accepted to a journal, the international the online international journal. I'm sorry, no, the International Journal of Online Graduate Education. But they were not submitted as separate research. They were submitted as a review of the literature um, to to provide readers with a summary of what the research said and specific steps you could take based on what the research said. In this case, it was a review of research and articles on how to effectively conduct a meta analysis or a meta synthesis. Um, Now, some of the qualitative, um, one qualitative type of research uh, that is particularly effective for or particularly fitting for clinicians is called a case study, where you collect a whole lot of information about an individual that you were working with. So you basically describe, usually what would happen in a case study is you would describe a treatment approach that ended up being effective for an individual you were working with. And the whole article would be about that one case. And so um, it wouldn't necessarily be quantitative. You might throw in some testing material that you had about the client, but it would all be about specific steps you took and specific analyses that you have about clinical interventions that you found to be effective. That is a case study is considered qualitative research. Other types of qualitative research do fit into clinical models. Um, Phenomenological research is a qualitative research approach that you might use with very detailed interviews of people, and sometimes you can get therapy clients to agree to conduct those interviews. You usually don't do them as part of the therapy session. You usually do them separate, but very often you can get clients to agree to sit down with you for a lengthy interview, which is usually what's needed for that sort of approach. Where am I going with this? Um, Quantitative research is more limited in the type of material that you can use uh, for um, for research. Meta-analysis is one of them. I have talked in this course before, and I believe I might touch on it before we finish, on what are called secondary data sources. Secondary data sources are where you can find data that has already been collected. Um, More and more journals are requiring this. More and more journals are requiring that when a person publishes a research study, that um, in their journal, that they allow for individuals to have ready access to their data. They have to make their data available. You can also find online secondary data sources where you can go to them and they will allow you to use the data that they have already collected. Meta analysis is where you take statistics, sort of the difference between statistical analyses using secondary data sources, and a meta analysis is that first one using secondary data analysis. You would use standard statistical procedures to analyze data that's already out there. Meta-analysis involves a specific type of statistical steps that are used to analyze um, results that are reported in the summary. So most of the um, statistical analysis used for meta-analysis use statistical results that are in the research studies, not gathered directly from the data. So what you would typically do for a meta-analysis is you would get a large amount of studies, all of which are addressing the same topic, and then you would pull from it statistics, standard deviations, correlations. I'll go through it. And then you would put those results into another statistical analysis that would basically analyze those results as if they had all come from the same data set. Okay, so let me go through it. What is a meta analysis? A meta analysis is a statistical procedure and a quantitative research method where the researcher seeks to integrate conclusions across multiple studies by applying statistical analyses to a group of studies, to groups of studies. So you would take results from a group of statistical studies, or you would take statistical results from a group of studies, and they don't all have to be from psychology research. They could be from research across disciplines. Um, a lot of meta-analysis cross disciplines. It may be from psychology and sociology journals. It may be one where two areas actually where a lot of the meta-analyses have been conducted lately have been cross disciplines studies between psychology and economics. One big field in economics lately has been behavioral economics. And so that's one area where there's a lot of cross discipline. Another might be psychology and medical research. Um, so there's another field where there's cross disciplines. So meta-analysis seeks to integrate conclusions across multiple studies and disciplines by applying statistical analyses to groups of studies. Some things that are done with meta-analysis is to get the central tendency of study outcomes. So that would basically being the mean, mode, and median, averages, standard deviation, standard variance, the measure of central tendencies across different results. I'll test the pattern of outcome variations. Uh, um, uh, what are the overall statistical results? Um, and then estimate the overall effect. So basically, conduct like ANOVAs and t-tests across, as if these study results were all from one source of data. Um, Meta-analysis um, is it is not the same thing as a narrative review. And what I mean by that is a narrative review is sort of is like the comprehensive narrative review is the same thing as the comprehensive literature review that I talked about before, which is a uh, you may very well see narrative reviews and meta-analysis on the same topics. The difference is narrative reviews don't have their own statistical results in them. They just summarize the findings and the conclusions from other studies. Meta analysis actually uses its own set of statistical procedures uh, to, uh, to describe outcomes. Um, okay, so let's talk a little bit about uh, what you have to have for a meta-analysis. When can you conduct a meta-analysis? When you conduct a meta-analysis, all your articles, all the articles you use have to be empirical. They have to have quantitative results. You can't do a meta-analysis from comprehensive literature reviews or narrative reviews or case studies or quality. You can't do meta-analysis from qualitative research. As I mentioned last week, I have two articles that I'm going to submit to you. One is on meta analysis. I do want you to read that um, for this course. Um, the other is on what is called meta synthesis, which is very similar to meta analysis. It uses its own analytic procedures for addressing articles, multiple articles all on the same topic. The difference is that metasynthesis is a procedure for qualitative research on the same topic. Metasynthesis is a statistical procedure for quantitative research on the same topic. Um, so um, um, so it has to be empirical. It has to have quantitative results rather than qualitative results. Um, Basically, it has to address the same topic, the same construct. So it has to be, you can't do a meta analysis with studies of depression and studies of anxiety. Um, yeah, and you can't do a meta-analysis of you can do one of depression and of anxiety, but you can't do one where you're taking um, studies of depression and mixing them in with studies of anxiety. And it has to have the same sort of relationships. In other words, you can't use studies of depression that are um, measuring depression and socioeconomic factors and combine them in with studies of depression and um, and age. But what you can do are combine studies of depression and age, even if they use different ages. So you could use maybe studies of depression in teenagers and studies of depression in um, adults. You would just combine them, and the age group would be across teenage and adult years. Um, they have to, um, you need, the other thing that you need for a meta analysis is you need studies where the results have comparable statistical form. So, for instance, you can't um, use studies that have ANOVA as their statistical results and have regression analysis as their statistical results unless the statistics in the ANOVA studies are similar to the statistics that are also included in the regression. What I mean by that is regression analysis very often includes correlations. Complex research designs will also often include um, correlations as part of their results. Basically, it doesn't matter which were the main statistics as long as you have the same statistical results in the research somewhere. So, for instance, very often, someone whose main, maybe they are testing their hypothesis based on their main test for the hypothesis is a regression analysis, but they may have also used an ANOVA somewhere in their research as they were building to their main um, statistical test. If you look at a lot of research, that very often happens. They will start at one point um, to sort of describe their data. So they'll give you a mean, standard deviations, that sort of thing. And then they will build up to where they test their hypothesis using a regression analysis. But along the way, they may further describe their data or draw further conclusions about what their data means based on an ANOVA. So if you have an ANOVA result somewhere in the study, you can use it um, as part of your meta analysis if your meta analysis is basically based on um, statistics related to an ANOVA. So for the most part, as you're seeing, the research that you use for uh, the research that you use for uh, meta-analysis, all the research studies have to be um, uh, the the studies have to be um, generally on the same topic and addressing the topic in very similar ways. Okay, I have some numbers here that I want to give you. So, um, when I mentioned before um, the that you have to have statistics uh, that are the same statistics in each study, even if the main one is something different. I mentioned correlation. Correlation often plays a very important role in meta analysis. Very often, it will be the statistic that you will use that you will try to gather from the research and put into your meta analysis statistics. And the reason for that is because um, correlation is at its very base a measure of what is called effect size. And in meta analysis, this is a very important point. In meta analysis, the dependent variable in your meta-analysis is the effect size. Um, and so correlation is um, correlation is a measure of not only shows the relationship between variables, but the correlation itself shows you the size of that relationship, the size of that effect, the size of the effect that one variable has on another. In fact, one set of numbers I don't think I gave you before, so I wanted to bring that up here, is if you have a correlation, a Pearson's correlation, remember, which is the small r, if you have the Pearson's correlation around zero point 0.1, that is considered to be a low effect size. If you have a Pearson correlation around zero point 0.3, that is considered to be a medium effect size. And if you have a Pearson correlation of around zero point 0.5, that is considered to be a large effect size. Now, just so you um, just so you uh, understand, effect size is different from significance. They very often are the same. I mean, you very often can sort of um, guess as to what the significance is going to be based on the effect size. If it's zero point 0.5 or more, that's almost always going to be significant. In fact, I can't think of a situation it wouldn't be. Zero point 0.3 is often significant, and zero point 0.1 is almost never significant. Um, um, but um, it does it does show that, and that's part of the reason for why it's different, because um, in when studying uh, significance, it's usually a yes or no answer. Um, is it significant or is it not significant? But um, point one, even if it's not significant, still represents the degree of effect size. You don't basically toss it out because it's probably not significant. Um, you can still use it. It does not, point one, just because it is not a significant relationship or statistically significant relationship, does not mean lack of relationship. In When we're talking about significance, it's usually a yes or no answer. Is it significant or is it not significant? And in fact, at the very heart, that's what we're testing, the null hypothesis. Um, the null hypothesis is testing testing the assumption that there is no relationship between the variables. And very often, what you're looking is a way to disprove that null hypothesis. But effect size is different. Effect size is not a zero point 0.1 uh, correlation between two variables. If something just came up on my screen on your side, I apologize. I don't know why that was popping up. Um, if a zero point 0.1 correlation between two variables may very likely mean the absence of any significance in terms of the variables being related. It does not mean the absence of any relationship between the variables. There is still an effect size. There is still a relationship. It's just small. By the way, one other term to give you, as far as another measure of effect size, is called Cohen's D, Cohen apostrophe S, and then little d. It is the effect size for a t-test or an ANOVA. Uh, and so, and really, the Cohen's D is very easy to calculate. Usually, I don't give you the statistical formulas for statistics that we use here because they're usually just more math than we need to have here. But with effect size, it's very straightforward. You take the mean of your experimental group, you subtract from it the mean of your control group. So if you have, this would be for a t-test. Um, um, and so uh, the mean of the group that receives the experimental treatment, um, subtract from the mean of the group that doesn't receive the experimental treatment, and then you divide it by the standard deviation, um, and that's your effect size. Um, and what that allows you to do is have an effect size for a t-test. There's also a similar formula for an ANOVA, but I won't get that. But and the other thing that allows you to do is you cannot. That is what when I talked before about, if you have a regression analysis and you have uh, research studies that use ANOVA and research studies that use regression analysis. I was talking before about how you can't use the results from those specific statistical tests because they're different types. What you can use are a mixture of Pearson correlation coefficients and Cohen's d, because they are both measures of effect size. So very often what you would do in meta-analysis is, if you have studies using a regression analysis, you will pull from it the correlation coefficients. And if you have studies using ANOVA, you will calculate from that um, effect sizes. And then you can combine those for your meta-analysis. So really what you are using in meta-analysis is primarily um, measures of effect size. And measures of effect size in statistics are correlations and Cohen's d. Um, and there's a couple of reasons why um, there are other measures of effect size. And any measure of effect size can be included. And that's why I said you can, for a meta-analysis, you can't use, the F value from an ANOVA and the slope value from a regression analysis. But you can calculate Cohen's d based on the ANOVA, and you will have the correlations from the regression analysis, and you can use those variables in your meta-analysis. You can use other effect sizes. There may be other effect sizes being used. There's a number of different measures of them. What they all have to be have in common is they have to be a comparable across studies. So they have to be um, the one thing uh, uh, Cohen's d and the correlation coefficient have is their values are both um, 0 to 1, so 0.2. You would drop the uh, 0.1. No, it'd be 0.1 or 0 to -1. So they all have to be within that range. The value of them has to be 0 to 1. So it has to be a decimal. Uh, um, the results have to represent both the magnitude and direction. Magnitude would be in the number. So 0.6 would be more a stronger effect than 0.3. Direction is whether there's a negative sign in front of it. Um, so remember, like for instance, in a correlation, a positive correlation would be a graph that goes like this. You know, variable x and y, as the value of x goes up, the value of y goes up as well. Um, a negative correlation would be like this. As the value of x goes up, the value of y goes down. So the measure of effect size that you use and both Pearson and Cohen's d, Pearson coefficient and Cohen's d have this in common. They are similar types of measures. They both measure magnitude and direction, and they are independent of sample size. Uh, um, uh, and that's the one way, I was talking before how effect size is not the same as um, is not the same as significance, and that's one of the differences. Significance takes into account um, sample size, your n, how many people you had. The correlation codes D do not take that into account. Okay, I will go through it, and you'll read this in the article. Each of the steps in meta-analysis, and I certainly expect we will need to pick this up at the in the class, but I'll get through as much as I can here. The first step, and all the steps are listed in the article. Now, the steps that are in the article might be slightly different than what I have in my notes, because what I have in my notes may have a little bit more detail as far as the steps go. Uh, but the first thing that you do is you formulate the research question. So you take a look at um, what your research question is going to be. What will guide the selection of studies that you use, how you will code the information, and what sort of statistical analyses that you will use. Um, and Just one example that I have up here from a meta-analysis, this is from a research study that was done in 2001. The questions that were asked of the meta-analysis were, it had to do with challenge programs. Challenge programs are these outdoor programs that are often used for juvenile probation, for juveniles who are getting in a lot of trouble. I guess the term used, well, I know the term used to be juvenile delinquents. That's not used that much anymore. Outward Bound is an example of a challenge program. This study was how effective are challenge programs in reducing the subsequent antisocial behavior of juveniles with behavior problems? What are the characteristics of the least and most successful programs? And do these programs have favorable effects on other outcomes, such as relationships with peers, locus of control, and self esteem? So, notice how the research questions can be very detailed, like that one. But another example from a study in 2008 simply after the meta analysis, the straightforward question was, how effective are neighborhood watch movements in reducing crime? Um, so those are some. Uh, so those are some of the questions that can be asked. I'm going to try to get through reviewing all the basic steps on a base level, and then we can talk about them in more detail when we meet on Thursday. What you then do with meta-analysis is you figure out what are your criterion for including and excluding studies. And some um, questions um, that you have to ask is, or you have to look at is, what sort of criteria you're going to set for sample size? Even if sample size, because sample size doesn't matter in the statistics you're going to use, you need to set your own criteria for making sure that the sample size was sufficient. I mean, depending on where you pull the research from, it may be a very low quality study, that maybe had only 2 or 3 subjects in it. So you need to be aware of the sample size. You need to make decisions about what sort of publications we're going to use. Um, are you going to include, and usually what type of publication means is um, basically the quality of publication. Are you only going to use the top tier publications like the APA journals? Are you going to use other journals? One question that comes up a lot anymore is whether people are going to use journals where the authors have to pay to get the articles published. Now that's become more frequent as far as availability in recent years. And there's sometimes criticism, of the quality of research. So you need to make your own decision about how are you going to set the criteria for the quality of journal that you're going to use. Um, and you have to decide what sort of study designs are you going to look for and what sort of data collection methods are going to look for. So you need to basically decide um, what you can include and what you leave out when it comes to things like sample size, type and quality of publication, type of study design, and how data was collected. And then you just go through the databases and start looking all over the place for all the different sorts of studies. Using only one or two databases, one or two uh, sources of studies is usually not acceptable. You need to go through a lot. Some examples of ones that we've already talked about. Some I know we already Google Scholar is one, um, and there's something called the International Bibliography of the Social Sciences, PsycInfo. Those are the big ones for psych. All the major databases for academic studies are there. Just two that I wanted to bring up that is in this list I have in front of me of databases that you want to keep in mind that may not necessarily jump out at you are the databases for dissertations. There's two: dissertation abstracts and dissertation and theses. Those are uh, you want to look through those too. You don't want to ignore databases. Databases can be used as well, even if they're not published as a separate article. Um, you then have to um, uh, develop a coding protocol, which kind of allows you to um, describe in a quantitative way what sort of studies you used. Um, and So you'll want to have some sort of rank or some sort of uh, quantitative, some sort of numbers that signify what sort of studies are used, what sort of interventions were used, what sort of research design was used, because those all may go into your statistics. You want to include confidence ratings if they were in the studies. Um, okay. Um, Sorry, I'm going through some of the other. So you want to get the effect size from each of the studies, um, and you want to pull out all the measures of different effect sizes. Um, okay, and then um, and then you would put all these uh, into a meta analysis. Um, and the meta-analysis will meta-analysis program, the statistics run, there are specific meta-analysis programs. One is called just comprehensive. The one I recommend, I've had several dissertation students do meta-analysis, and the one I recommend is comprehensive meta-analysis 2.0. One statistic that is important for a meta-analysis that you may need to calculate on your own from the data you have is small letter d. That's the main statistic that's used um, in a meta-analysis, and there's formulas. Usually the comprehensive meta-analysis will do it, but there are basic formulas that take the correlation or the Cohen's d that you have, um, and convert it to um, and I'm sorry, no, I apologize. The d that's used, basically what a meta-analysis does is, um, you can put in a Pearson correlation coefficient or a Cohen's d, but in the end, in order to conduct a meta-analysis, the statistical program converts them all to Cohen's d. So what I have here is the formula for converting uh, correlation to uh, Cohen's d, but you don't need to know that. It's just you need to convert. The program will do that. Now there are some meta-analysis programs that do the opposite. They convert the Cohen's d to a correlation. So in the end, the meta-analysis is all using the same statistic. Most are converting the correlation coefficient to that Cohen's d. Some, not the comprehensive meta-analysis, but some will do the opposite. They will convert the Cohen's d to a Pearson's correlation, and then you just run the program, and what you end up getting is the overall effect size um, uh, for uh, across the board. And so uh, I'll go through those statistics when we meet on Thursday. But then what you also would do, uh, following those results, is you would compute not only effect size, but you would also compute what the variance is in your across the studies. You would determine uh, the effect size, its significance, the variance, and then what is interesting too about meta-analysis is it often allows you to calculate what is called publication bias. And publication bias is uh, is is based on the assumption that there are studies that are missing, studies that you missed, and that's usually in part because based on the um, uh, based on the likelihood that only large studies and only studies that only studies that found significant results are likely to be published. So there's a bunch of statistical tests that you can use for determining whether there was publication bias. And then you would incorporate that, and then you would that would be your meta-analysis, and then you would interpret it. So I want to go through that. We'll talk more about meta-analysis when I review the article with you on Thursday. So we'll stop from there, and I'll see everybody on Thursday.